Okay, hello everyone. Welcome back to another tutorial on Art Studio. In this tutorial, I'm going to show you how to run Factorial Anova using Art Studio. So as usual, the very first step is to set your working directory or identify the folder that you will be having your data file, R script file, and also setting it as a working directory. So firstly, go to the directory option, the three dots here, click on it and set the working directory. Okay, so once you select on the three dot, it goes to your folder that you would like to select. So in this case, I have set it in my pen drive. So and I click on my demo folder, which is the place I keep my files. Okay, so specifically under F test. Okay, now my pen drive G drive demo and under ftest folder. Okay, now I wanted to set this as my working directory. So I'll go to more, click on more, set as working directory. Now if you notice under my console, it is already in blue. It's showing that it is being set as my working directory. Okay, now I would like to select my R script. I've already prepared my R script, so I can just click on this Factorial Anova.R. So once I clicked it, if you notice on the left hand upper window, there is a new window that just appeared. Okay, so this is the script or the line by line instruction that we are asking the R Studio to run for us. Okay, the very first step is the working directory. We have already set it, but remember in your file, when you are running it, you have to set it at your own directory. So if you notice, initially mine was called as E, and now when I set it in this computer, it becomes G. So what I need to do is I have to change my working directory, because later if I want to rerun it, I don't have to set my working directory multiple times. So when I remove this, so how do I get my working directory here? Go to history. The very last option that I did here is actually setting the working directory. So I can highlight this and move it to my source. Click on source, it moves here. Okay. Now the second step is to load the library that I need. So I need the stats library, psych library, and also library called car. Okay, these three libraries need to be installed. Okay, if it is already being installed, we just need to activate it. So how do we actually activate it? We just have to highlight them or select all of them and click run. So once you click run, you notice it shows that all these blue lines, and then there are some functions. Okay, when you see, don't worry when you see a red color message. Okay, this message means that psych and car package, okay, both of them has similar functions. So you have to be careful on which one you are actually using. That is what it means. Okay. Now once you have activated, the third step is to import the data file into R. So always you have to set the working directory, select the package. Now you call in the data. So in here I have named it as data. Please read the CSV file called data for one and two way .csv. So it is actually appearing on my folder, my F folder, ftest folder. There is a file. Okay, so I'm going to call in this file and name it as data. Okay, so it is already, it's showing there is a blue line here, blue command, the function has been generated. So how do we know the data is already in? We go to environment, then you see data 48 observation with 3 variables. So when you click on it, you see there is a day, type, and inquiry. So I have 3 different variables. Okay, with 48 observation. Now, once I have my data in, first thing is I need to test the assumptions. I need to test if the data is suitable or ready for the analysis or not. So the first thing is to test for normality. Okay, normality meaning is your distribution normally distributed. What distribution? Your dependent variable. In this case, in this example, I would like to see if the number of inquiries that a TV station gets is it subjected or is it influenced by the day that the advertisement is being posted, and also in which channel or in which program that this advertisement is being played. Okay, so the day meaning whether it's on a Monday or Friday. The type here meaning whether when the advertisement is being posted during news, during business, or during sports program. So we want to know, does the number of enquiries we get for an advertisement, is it being influenced on the day it is being aired or on the program that is being shown? Okay, so there are two factors, whether it's a day or the type of program that is being played. And do these two factors have any influence on the number of enquiries they get on the advertisement? So we would like to see, so what we are going to see here is the first line here on the 15 is described by the inquiry variable, okay, the dependent variable, is it normally distributed by the day variable. So the day we have Monday and Friday. So we want to see if they are normally distributed. Then the 16th line is whether we want to see the number of inquiries that we get, are they normally distributed across news, business and sports program. Okay, so we want to see if there is any differences or not. Okay, so I can highlight both of them and click run. Okay, this described by is actually function that we get from the site package. Okay, now for the first one, for the day, if you notice, Friday and Monday. So it tells us all the descriptive information for Friday, for all the inquiries that received on Friday, and the following one is the Monday. And we look at the skewness, both of them are plus minus within the range, okay, plus minus 2, the range of plus minus 2. So they are normally distributed. Now the skewness for the inquiry by different programs, the type of program, whether during business, news or sports. So when you look at the skewness is still within plus minus 2, within the range. So the normality has been accepted for both the factors. Okay, normality is being met by examining for both factors. Next is test of independence. So again, the independence is whether your observation that you get are independent to each other. Does it being influenced by another participant in your data? So that is being, there is no test to look into it, but it can be assured from the the way that we collected our sample. Okay. Next is homogeneity of variance. So this is also important. We would like to see if the variability or the variances across the two groups or three groups are similar before even we run any analysis. Because when you want to make comparison, although they are different groups, but you want to make sure that people in the groups are similar although they are in the different group, because only then you can make the comparison. So we want to test it out. So firstly, we test it out for factor day. Okay, so for there's two factors, day and type. So we would like to see for the day first. So we would like to see, is there any differences in the variability between Monday and Friday for the inquiry variable. So we run a var.test, so variance test. And this is only when you have two groups. When you have more than two groups, because type we have three groups, we have business, news and sports. So if you have three groups, you have to run Levene's test. Okay, so in this Levene's test, we are looking at the inquiry by type. Okay, so again, the one before, the data $ inquiry, meaning the inquiry and type are variable that being extracted from the data set called data. Okay, so once we select all of them and click run, okay, so you will get the results on the console. So the first one is F-test to compare two variances. Okay, so two variances, always look at the p-value. This probability value If it is greater than 0.05, meaning the variances are equal. So here it shows yes, it is equal. So the variance between, there is a similar variability between Friday and Monday's number of enquiries. The next one is for type. So between these three types, is there any differences? So we look at again the probability. It shows it is greater than 0.05, meaning that there is no differences in the number of enquiries received for different programs. Okay, whether the variability that we get in the data are not different across these three groups. Okay, now once all these assumptions are being met, we are going to run the analysis. So I'm naming it here as two-way. Okay, run analysis of variance. Okay, my dependent variable is inquiry, and then as factor. Okay, my first factor as type, and then this is actually a star or multiples. You just like having a multiplication sign, and then as factor day. So this is factor 1 and factor 2. If you have another factor, you just have to add a star. Okay, asterisk mark, and then followed by as factor. Maybe you'll have another factor. Okay, so just you have to add it, and then you have to specify where is this information will be extracted from. So data, how do you call this data file? As data. Okay, so now when you run it, okay, when you highlight and you just run, you see your data appears here. So if you want to highlight, you have to highlight the entire line. So click on it. It ran successfully. So what will be the result? So you have to click summary of this two-way ANOVA. So click on it. Yeah, so you have the factor A, factor B, type and day, and then the interaction between type and day. The degrees of freedom, the sum of squares, mean squares, F values, and the probability values. The residuals here means the within. Okay, so what you need to check it out? You have to check it out the interaction. Always check the interactions probability value. So if this one is significant, less than 0.05, then you have to run a follow-up analysis. You don't have to interpret factor and day, because factor and day are interrelated. That's why when you have an interaction, meaning for a particular day and particular type of program, they have different number of inquiries. So we want to identify where exactly these things happens. Okay, so for that you need to do a follow-up analysis. So this follow-up analysis I will show you in the next video. Thank you very much.